So the next collection that I'm going to discuss is the set interface. So set is the way we use in the mathematical operation set, like it is unordered collection list which where duplicate is not allowed. So once you create the set interface and allocate some collection object to it, you could perform the mathematical operation set there. And the set interface have like the sorted set and the navigable set that you could use as an implementation of the set interface. So there are certain operations that you could run on the set. Let's say there are two values, 1 2 3 and 3 4 5. So if you will do the intersection of both of them, so you will get a value as a 3. If you will do the union of them, so you will get all values except 3, which is the common between them. And the difference, if you will do the difference between the two sets, so you will get 1 and 2, and 3 4 5 will be removed. So the same example that I'm going to show you in Java example. So for the basic operation, I could run the set like this. It will be the similar to any other collection. And if I will show you the example for the you know uh, the union, the intersection and the difference, so this is what the result of the all these operations. So if you could see, like for the union you will get all values except the common one. For the intersection you will get only one 3 value, which is 3, because this is the only common value between the two sets. And for the difference, you are going to get only the 1 and 2, and all 3 4 5 will be removed from the difference. So that is what the difference between union, intersection, and the difference in the set operations. The next collection that I'm going to discuss is the hash set. So this is one of the implementation of the set interface. So hash set actually store the elements into the hash set collection by using the mechanism hashing. So it internally actually use the hash map that we will discuss when we will discuss the map interface in the next session. So hash set actually contains the uniquely values in elements. It allows the null values as well. It is not synchronized, so it is not thread safe. So it the hash set doesn't maintain the insertion order, unlike in the list. So elements are added into the hash set based on their hash code only. So if you have like the frequent search operation, then hash set is the best collection to have. The default capacity of the hash set is 16 and the load factor is 0.75. So the another collection that I need to discuss is the linked hash set. So hash set is all another subset of the set. So it provides the data storage through the hash table instead of hash map or the hashing. It use the hash table. So and the internal structure it actually worked on the linked list data structure. So it contains the unique values into the linked hash set, and it provide all the operations for the null elements as well. So it is non-synchronized. That means it is not thread safe, and it also maintains the insertion order because it is internally a linked hash. Implement the linked list. So the third one is the tree set, which implement the set. So it contains the unique element, like we discussed in the hash set, and retrieval is very fast because internet use the tree structure as a data structure. So it do not allow the null values. It is non-synchronized. It always maintain the ascending order by default. The access and retrieval is very fast. So if you have something you need to quickly access during the iteration, then you could use the tree set. And so if there will be like any kind of you know comparable, you have to use the comparable, and you have to implement the string buffer class. If you could see, like, I could add two div instead of one, and I will iterate it, so it will be the only one div instead of two. The reason behind, like, whenever we add any value into the hash set, that values hash code will be generated internally. So if there will be like two hash code for the same, I mean same hash code for the two values, it will keep only the one, right? So this is how hash set work. So another example is the tree set that I need to discuss. So this is the example. So we could add values into the tree set like this. It will be the same, right? So we could iterate the tree set in a particular manner. Let's say we are iterating in the descending order. We could poll first and the poll last. Also, we could set the descending order. We could set the head. We could set the subset. We could set the tail set. So all these methods can be implemented into the tree set. I need to check what are the files I have added. So these are the files that I have added. So I will simply say git diff. See, these are the things, and some of variable I have changed. So I will say git add, and I will say git status. These are the some of the new files and the modified files. So I will say I don't want to add the class files, so I will simply go here and I will go to the project programming Java SE. I will simply remove this bin directory because I don't want to add the class files. So I will say git status, git add, git status. Now only the Java files are there. So I will say git commit -m set examples git push. Once it is pushed, you could simply download it from the git. So I will share it with the description in each video.